In part 5 of disk and file system management, we'll look at actually placing a file system on a partition. So far, we've inserted a disk into our virtual environment. We've partitioned it using a number of different tools. And now it's time to actually put a file system on top of it. You can think of a file system very similar to priming a wall or priming a canvas for paint, right? We put this coat on the canvas itself before we can actually draw anything on that canvas. File systems are similar in their function. They allow us to, once they've been put on or written to a partition, they allow us then to save data to that partition. There's a couple of different file systems. Well, there's more than a couple actually. There's a bunch of different file systems we can use in a Linux environment. We'll look at primarily the ext file system in its various forms, but you also have XFS, Riser, and others. Which one you choose really just depends on the situation. Then we'll look at formatting the partition with the mkfs utilities that are available to us. All right, so now let's look at actually putting a file system on, formatting the partition, if you will. In a Windows world, you may have used the format command in the past, and this is traditionally something you might have seen happen. In Linux, we use the makefs command, which is similar to what the format command can do. Now, makefs has many different options, and those options are because we have lots of different file systems that we can actually format our partitions in. If I tab it out from here, you can see right now these are the file systems that are available to me by default on our machine. We have the ext versions over here. We also have some older Windows versions that we could use if we needed to for some reason. Something like vfat. Typically, the only time I would ever use vfat in a Linux environment was if I was trying to share between dual booting Windows and Linux machines, just so Windows could actually get to some files. In a Windows world, we really have two options. We have NTFS and vfat, or FAT32. And really, NTFS is really the only viable option. The only time I use vfat typically nowadays is if I have a USB device that needs to go into something like a DVD, that I have a video that I want to watch and the DVD cannot read either the Linux file systems or the Windows NTFS file system, so I format in vfat so that the system can read it. But there's lots of limitations with vfat, and I would avoid using it at all costs in a Windows environment if I had to. In Linux, we have ext2, which is similar in its ways to vfat, and it has some limitations, which would also force me to shy away from using it. It's an older version of the ext file system. Then we have ext3, which brought in something called journaling into the ext file system, and that's the difference between vfat and NTFS, along with file sizes and maximum capacity, is really the ability to journal. So NTFS is a journaling file system, and ext3 is also a journaling file system. What that means is, if vfat or ext2 were to crash, you had a box and it crashed with that file system on it, when the system comes back up, it has to check the entire disk. So if we had gigs and gigs and gigs of information, that would take a long time to do. But it has to do it because it's a non-journaling system. A journaling system like ext3 or NTFS actually writes a log. So if the system crashes, what happens when it comes back up? It just reads its log to see what is different and what needs to be backed out. And that's why they were so much quicker at recovering, and it's one of the reasons you really want to use them. So we're going to actually format the disk that we created with the fdisk utility. So I'll take a look at what we have right now. So we have this disk right here. I took the whole space. It's ready for a Linux partition. I'll clear this out. And we can type the makefs command. Now, if I want to, I can do it the old way, and I can say makefs -t ext4, which is the modern version of ext, and then I can tell it dev sdb1. Go ahead and format that. It comes back, it does it really quick because it's fairly small, but there is some interesting information I want to point out to you in here. First of all, if you look right here, it talks about reserved blocks right up here. There it goes. By default, if you don't tell it not to do this, it will reserve 5% of the disk space for the root user. Why is it doing that? It probably has something to do with the typical admin philosophy that you don't provision all your space out to users, because if you give them all the space, they'll use it all. So what we're doing is holding 5% off to the side that could literally be put back into the system instantaneously without having to remount the system to get it. So 5% doesn't seem like much, but if we're talking a terabyte, that's 50 gigs. So in a modern drive, it's a lot of space. Now, if we want to, and we want to actually provision it all out when we create the system, what we would do is type the M with a 0, which means reserve 0 blocks on this file system. So remember, 5% was showing up before. We'll press enter now. And if we go and find the reserve blocks right here, we see it's 0. So if you know that you're going to be creating an ext file system and you want it to be, all of it to be used, you want to make sure you're using that -M option. We can also modify the inodes, the number of inodes on it. I don't know why you would necessarily want to do it, because that's the maximum number based on the size that we have, but we can do it if we want to. And we could also give it a label. This we'll talk about when we get into mounting, but we can give it a label that we can then use to mount the file system later on. So let's get down here. So let's kind of string that all together now. So we'll say mkfs, and I'll say type ext4, and I'll say inodes equal 128, m blocks, lowercase m, 0, and then dash label is going to be sales. So all that information, and I'm saying on dev sdb db1, just like that. And if we press enter again, all right, we get the same type of stuff here. We can see now that the inodes, there's 128 inodes, and if you remember, that means you'll be able to create 128 files on here. Whether they're empty files or full files, that's all you'll be able to create, because that's what inodes are. They are the placeholders for files. We can see now it has a label of sales, which I could use to mount it if I wanted to, and we have reserve blocks of 0. It says it is a journaled filing system, right? So it's journaling, and that'll take a little bit longer when you're formatting it, but because we're so small, it doesn't matter. If we wanted to, we could type makefs dot, press enter, and I could just type makefs dot 4, and that eliminates me from having to do the whole -t ext4. So that's probably the way I would do it, since my typing is horrible. So I would type that, then after that it's the same. We can say, you know, reserve 0 blocks, label everything else, and we can give it dev sdb1. Now remember, I'm always putting a file system on a partition. I am not putting it on a disk. If I try to do that, right, I'm not going to get anyway. So you can, if you want to, use a disk without a partition, which we'll see when we get into LVM. It's not something that you would do with the makefs command typically. So typically we'd be giving it a partition. So we'll say no here, and we'll give it a partition to actually format, and go ahead and do it that way. So that's an introduction to actually putting a file system on the partitions we've created. Next, we'll look at mounting it. Well, what good is it if we have a file set, we have a partition, we have a file system, but nobody can access it because it's not mounted anyplace. So next, I'll show you how to take what we have here and actually mount it so users can use it.